In this video, we will see the definition of sphere and different equation of sphere, that is the equation of sphere in different forms. So now first we will see what is the difference between the circle and the sphere by using a small video. We will see the difference between circle and the sphere, so by using one demo. So we know the definition of circle. Circle is the locus of point whose distance from some given point is always fixed. So suppose this is one fixed point and we consider some fixed distance between these 2 points, gray and this pink. I just drag this pin point, see what happens. Drag it continuously. So it will form a locus, and this locus is nothing but a circle. So circle is the set of points that are equidistant from a fixed point. That is, all the points on this green curve shows the set of points on the circle, and they are equidistant from this gray point, that is fixed point, and that is called center, and the distance between this gray and this pink point is the radius of this circle. So circle is a two-dimensional object or two-dimensional figure. Okay. Next we will see definition of sphere. For that, see this animation. See, I just drag this point and see what happens. So if you drag this point continuously, it covers all the point on the given surface. So this form a sphere. So just like a circle, sphere is the set of points that all are equidistant from a given fixed point, but in three-dimensional space. So this fixed point is called the center of the sphere, and the fixed distance is called the radius of the sphere. So already we see the definition of sphere. Again, see definition of sphere. So sphere is nothing but the set of points that are all at the same distance or equidistance, say r, from a given point, say C, in three-dimensional space. So here C is the fixed point, and we consider r as a fixed distance. The fixed distance is called the radius of the sphere, and the fixed point, that is C, is called the center of the sphere. Next we'll see the equation of sphere in center radius form. So for that we consider a sphere with center C and radius say r. Then by definition the distance Cp is equals to r. Squaring it we get Cp square equals to r square. Now find the distance Cp by using distance formula. For that, suppose C has coordinates a, b, c and P has coordinates x, y, z. Then by using distance formula, Cp square equals to r square becomes x minus a bracket square plus y minus b bracket square plus z minus c bracket square equals to r square. This is the equation of sphere in center radius form. Next is the equation of sphere in general form. So again consider equation of sphere in center radius form. Now if we solve this equation, we will get the equation of this form. So denote this equation by equation 1. So in this equation, we put minus a equals to u, therefore a is equals to minus u. Similarly, put minus b equals to v, put minus c equals to w, and the last term a square plus b square plus c square minus r square equals to d. Solve this equation for r. So we'll get here r is equals to square root of a square plus b square plus c square minus d. Here we consider the positive square root of this number because we know that the distance r is always positive, which is the radius of the sphere. Now substitute all these values in equation 1. So equation 1 becomes x square plus y square plus z square plus twice ux plus twice vy plus twice wz plus d is equals to 0. Now this new equation and the original, that is equation first, represent the same sphere. So they have same center and same radius. So center of sphere 1 is ABC. Therefore, the center of this new equation is minus u minus v minus w. That is, if the equation is expressed in this form, then its center is minus u minus v minus w. This form is called the general equation of sphere. Similarly, the radius of sphere, if it is in general form, is r equals to square root of u square plus v square plus w square minus d. Next, we will see the equation of sphere in diameter form. So, for that we consider a sphere with center C and consider any one diameter. Diameter is the largest chord which is passing through the center of the sphere. So here we consider the diameter AB with extremities, that is endpoints A and B. A has coordinate x1, y1, z1. B has coordinates x2, y2, z2. Take P is any arbitrary. P is an arbitrary point of the sphere. Suppose its coordinates are x, y and z. Then join this triangle or complete the triangle APB. So this triangle APB is a right angle triangle. So to find the equation of sphere in diameter form, we require the DRS of these two lines AP and BP. So actually this is the equation of sphere in diameter form: x minus x1 into x minus x1 into x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2 equals to 0. To obtain this form, first we consider the DRS of AP, and that DRS are A1 equals to x minus x1, B1 equals to y minus y1, C1 equals to z minus z1. That is, we have to take on here the difference between the corresponding coordinates of the point A and B in one direction. So similarly, find the DRS of the line BP, and that DRS are A2 is equals to x minus x2, B2 equals to y minus y2, and C2 equals to z minus z2. So already see we have to saw that this is a right angle triangle. So line AP is perpendicular to line BP. So using the condition of perpendicular condition in terms of DRS, that is A1 into A2 plus B1 into B2 plus C1 C2 is equals to 0. Put the values of A1 B1 C1 A2 B2 C2 in this condition. We get equation of sphere in diameter form, and that equation is x minus x1 into y x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2 is equals to 0. We have learned three forms of the sphere. First equation is equation of sphere in center radius form, which is x minus a bracket square plus y minus b bracket square plus z minus c bracket square equals to r square. Its center is a point ABC and radius is r. Second is general form. This is general form of the sphere. The center is at point minus u minus v minus w, and this formula gives the radius of the sphere. Third one is equation of sphere in diameter form. This is equation of sphere in diameter form. Solving this equation, we will get the general form of the equation or equation of sphere in general form. And using these two formula, we will easily calculate the center and radius of the